Today we're going to extend what we did yesterday. Yesterday we used the iPad to look at the bisectors of triangles, perpendicular bisectors and angle bisectors, and the points of concurrency that they have. And we said those points of concurrency were the circumcenter and the incenter. Let's take a real quick review of what we did yesterday before we get to our objective, which is going to be to identify properties of perpendicular bisectors and angle bisectors. So the first figures we looked at, the first bisectors were perpendicular bisectors. And we said that point of concurrency of the perpendicular bisectors of a triangle is called the circumcenter. And that circumcenter was equidistant from the three vertices of the triangles, all right, the 3 points on the triangle. The other point of concurrency we looked at was of the angle bisectors, and that was called the incenter. And the incenter was equidistant from the 3 sides of the triangle. So there's a couple things that you're going to have to remember, and you're going to have to put in your notes, is that where the perpendicular bisectors all meet, that point of concurrency is the circumcenter, and it's equidistant from the vertices. And the other one is the angle bisectors, and they all meet at the incenter, and that incenter is equidistant from the sides. So make sure you have that in your notes. The first example we're going to look at is finding the circumcenter of a triangle, and we're going to do that in the coordinate plane. And this module will take you through how to find the circumcenter of a triangle.
In this problem, you will find the circumcenter of a triangle. What are the coordinates of the circumcenter of a triangle with vertices P at 0, 6, O at 0, 0, and S at 4, 0? Draw a triangle with vertices at the given coordinates. Find the intersection of 2 of the triangle's perpendicular bisectors. Here it is easiest to find the perpendicular bisectors of segment PO and segment OS. Step 1. Point 03 is the midpoint of segment PO. The line through point 03 that is perpendicular to segment PO is y equals 3. Step 2. Point 20 is the midpoint of segment OS. The line through point 20 that is perpendicular to segment OS is x equals 2. Step 3. Find the point where the 2 perpendicular bisectors intersect. The lines x equals 2 and y equals 3 intersect at point 2, 3. The circumcenter of the triangle is at point 2, 3. Does the location of the circumcenter you found make sense? Yes. Triangle POS is a right triangle, so its circumcenter should lie on its hypotenuse.
You're going to have a couple of examples like this in your Math Excel, a couple problems. So I would suggest when you see these, when you're dealing with coordinates, to grab some scratch paper or grab some graph paper off the back table. Don't try and do them in your head. Go ahead and grab some graph paper as you're working these problems. The second problem we're going to look at is an application of using the circumcenter, and that is trying to find where, in this example, we're going to try and find where to build a fire station, and we want it to be equidistant from 3 different locations.
In this problem, you will use a circumcenter. A town planner wants to locate a new fire station equidistant from the elementary, middle, and high schools. Where should he locate the station? How do you find a point equidistant from 3 points? As long as the 3 points are non-collinear, they are vertices of a triangle. Find the circumcenter of the triangle. The 3 schools form the vertices of a triangle. The The circumcenter is where the perpendicular bisectors of the sides intersect. You only need two lines to find a point of intersection. Draw the perpendicular bisector of segment HE. Now draw the perpendicular bisector of segment HM. The planner should locate the fire station at P, the point of concurrency of the perpendicular bisectors of triangle EMH. This point is the circumcenter of triangle EMH and is equidistant from the three schools at E, M, and H.
So remember, when you're finding the circumcenter, that point is going to be equidistant from the three vertices of the triangle. The next example we're going to look at deals with the incenter, and the incenter is the point that is equidistant from the three sides of the triangle.
In this problem, you will identify and use the incenter of a triangle. The length of segment GE equals 2 times x minus 7, and the length of segment GF equals x plus 4. What is the length of segment GD? Determine whether point G is the incenter of triangle ABC. Segment CG bisects angle C. Segment AG bisects angle A. Segment BG bisects angle B. Point G is the incenter of triangle ABC because it is the point of concurrency of the angle bisectors. The distances from the incenter to the three sides of the triangle are equal. What is the distance from a point to a line? The distance from a point to a line is the length of the segment that starts at the point and is perpendicular to the line. So the length of segment GE equals the length of segment GF, which equals the length of segment GD. Use this to find x. Use the length of segment GE equals the length of segment GF to find x. Substitute 2x minus 7 for GE and x plus 4 for GF. Add 7 to each side of the equation. Then simplify. Subtract x from each side of the equation. Then simplify. Now use the value of x to find the length of segment GF. Substitute 11 for x. Then simplify. Since the length of segment GF equals the length of segment GD, the length of segment GD equals 15.
So most of the problems in your Math Excel homework for today in Lesson 5.3 are going to be solving problems where you have to decide, do you have a circumcenter, that is a point that's equidistant from the three vertices of a triangle, or do you have an incenter, and that's a point that's equidistant from the three sides of a triangle. So you can use this video and the examples in the video to help you through your Math Excel homework.